In 1977, humanity sent two small spacecraft into deep space. Their task seemed straightforward: study Jupiter and Saturn, collect data, and eventually fade into silence. At that time, space exploration felt ambitious but still limited, as if each step would be slow and controlled. But the journey of Voyager 1 turned out to be anything but ordinary. A rare alignment of the outer planets created a unique pathway through the solar system. This alignment, which occurs roughly once every 175 years, allowed a spacecraft to use the gravity of multiple planets to accelerate and redirect its path. This technique, known as a gravitational assist, made it possible to travel much farther without additional fuel. Voyager 1 was launched at exactly the right moment to take advantage of this opportunity. Soon after launch, it did something unexpected. It turned its camera back toward Earth and captured a distant view of our planet alongside the Moon. From that perspective, Earth appeared incredibly small, just a faint point of light surrounded by darkness. It was a powerful reminder of how isolated and delicate our world truly is. In 1979, Voyager 1 reached Jupiter. What it observed reshaped scientific understanding almost immediately. Jupiter was not a calm giant but a turbulent world filled with massive storms and intense energy. Some storm systems were larger than Earth itself. The planet was surrounded by strong radiation belts, creating a harsh and dynamic environment. One of the most surprising discoveries came from Io, one of Jupiter's moons. Voyager 1 observed active volcanoes erupting on its surface, sending material far into space. This was the first time volcanic activity had been seen beyond Earth, proving that other worlds could still be geologically active. Another moon, Europa, revealed a different kind of mystery. Its icy surface was covered in cracks and lines, suggesting movement beneath. Scientists began to suspect the presence of a vast ocean hidden below the ice, possibly larger than all of Earth's oceans combined. This raised the possibility that environments capable of supporting life might exist elsewhere in the solar system. Voyager 1 continued onward and reached Saturn in 1980. There, it uncovered even more complexity. Saturn's rings, once thought to be simple and uniform, were revealed to be made up of countless narrow bands, constantly shifting and interacting. The system was far more dynamic than anyone had imagined. The spacecraft also identified new moons. One of them, Mimas, stood out because of a massive crater that gave it a striking appearance. However, the most significant finding at Saturn was Titan. This moon had a dense atmosphere that completely hid its surface. Even without seeing it directly, scientists detected chemicals that suggested methane behaved similarly to water on Earth, forming clouds, rain, and possibly lakes. This showed that liquid cycles could exist in very different forms on other worlds. The encounter with Saturn changed Voyager 1's trajectory. The planet's gravity pushed it out of the flat plane of the solar system, ending its journey to other planets. From that moment, it became something new, a traveler heading into interstellar space. As the years passed, Voyager 1 moved farther from the Sun. The solar influence gradually weakened. Then, in 2012, it reached a major milestone. Instruments onboard recorded a sharp drop in solar particles and a rise in cosmic rays from outside the solar system. This marked its crossing of the heliopause, the boundary where the Sun's influence ends. This transition was not smooth as expected. It was more like crossing an invisible line between two distinct regions. For the first time, a human-made object had entered interstellar space. Even beyond this boundary, space was not empty. Voyager detected subtle vibrations in the surrounding plasma, like a faint, constant hum. These signals revealed that interstellar space has structure and activity. The solar system itself exists within a region known as the local bubble, created by ancient stellar explosions. This area helps shield us from intense radiation, acting as a kind of protective zone in the galaxy. Voyager 1 continues its journey today, moving farther into the unknown. Its signal grows weaker with distance, but its mission remains one of the most remarkable in human history. Carrying a message from Earth, it stands as a reminder that even the smallest beginnings can lead to extraordinary paths. As Voyager 1 moves deeper into interstellar space, distance begins to take on a meaning that is difficult to fully grasp. Every second, it travels farther from Earth, adding thousands of kilometers to a separation that is already beyond imagination. Its signals, moving at the speed of light, take more than a full day to reach us. By the time we receive a message, Voyager itself is already millions of kilometers farther away. Communication has become a delicate process. The spacecraft transmits with extremely low power, weaker than a household light bulb. Yet massive antennas on Earth are still able to detect its faint signal. This connection, stretched across billions of kilometers, is one of the most precise and fragile links ever maintained. Inside Voyager 1, systems built in the early 1970s continue to operate far beyond their expected lifetime. Its power source, a radioisotope generator, slowly loses strength each year. Engineers carefully turn off instruments one by one to conserve energy, extending the mission for as long as possible. Each remaining system is managed with precision, as there is no possibility of repair. Temperatures in deep space are incredibly low, and without enough power, the spacecraft risks freezing. Despite this, it continues to function in an environment that was never part of its original design limits. Every piece of data it sends back is valuable, offering insights from a region no spacecraft has explored before. Beyond the heliopause, Voyager 1 is no longer influenced by the solar wind in the same way. Instead, it moves through interstellar plasma shaped by distant stars and ancient cosmic events. The spacecraft has detected variations in this medium, showing that it is not uniform. There are changes in density, magnetic fields, and energy levels, revealing a complex and dynamic environment. One of the most intriguing aspects of this journey is the concept of isolation. Voyager 1 is now so far from Earth that it exists in a region where the Sun is just another bright star among many. The familiar structure of our solar system no longer surrounds it. It has truly entered the space between stars. And yet, Voyager 1 carries something deeply human. Attached to it is a golden record, a collection of sounds and images chosen to represent life on Earth. It includes music, greetings in multiple languages, and natural sounds from our planet. This record is not meant for immediate discovery. It is a message intended for a distant future, perhaps millions of years from now. The chances of it ever being found are extremely small. Space is vast beyond comprehension, and Voyager's path does not aim toward any specific star system. But the purpose of the record is not just to be discovered. It represents an idea, that humanity chose to send a piece of itself into the unknown. Over time, Voyager 1 will continue drifting through the galaxy. Long after its systems fall silent, it will remain intact, carrying its silent message across interstellar space. It may pass near other stars, though that will take tens of thousands of years. Even then, the distances involved mean it will likely remain unnoticed. Eventually, Earth itself will change. Civilizations may rise and fall. Languages may evolve or disappear. But Voyager 1 will continue its journey, unaffected by what happens here. It will become a relic of a distant past, a reminder that at one point in time, a species on a small planet looked outward and decided to explore. In that sense, Voyager 1 is more than a spacecraft. It is a symbol of curiosity and persistence.